Angel Rocha Galvan. I will present you teacher our final project. This video is, I hope, will be short, but I will try to explain the statements of the problem of the how the quantum computer is going to change our lives. And next to me, my partner Jacqueline will explain the possibilities of the quantum computer and how this will change our life. So I believe it's important to define what is a quantum computer, but before that we need to define the statements of the problem. Well, actually our capacity of processing data is defined by the number of the transistors we can put into the processor. Now, the processor is like a brain of any cellular phone or laptop computer. So in recent years, the capability of producing or put these transistors into them, it's being diminuted, because actually a transistor has a size of nanometers. It's like 20 or 50 times smaller than a hair. So yeah, this is the statement of the problem. In the near future, we cannot produce processors with more capability of processing data. So this is where the quantum computer is going to save us. So yeah, what is a quantum computer? Well, basically we have a definition. It's a short definition of this. So this what quantum computing is, computing, like I say. So this use the capability of an application of the quantum mechanics. Quantum mechanics tells us about particles in order, like electrons or protons or neutrons, and these particles have a special behavior and have a special characteristic that we use them in the quantum computer. So this is basically a computing using these applications of the quantum mechanics for processing data at a speed like we never seen before. So what's in a quantum computer? A quantum computer, basically, it's a huge computer, like we can see this in this image. So basically, the quantum computer is in the point of this picture. The entire pipes and tubes we can see, it's just for keep them frozen in a very lower temperature to have a better function of this quantum computing. So yeah, this is quantum computing. Basically, what is a qubit? A qubit is a more elemental particle inside of the quantum computing. This is basically, we can define like a logic gate. A logic gate is located in a transistor between 3, 4, 5, 6 transistors, and this transistor we solve algorithms. So yeah, the qubit is this. It's like a transistor, but the difference and the properties that this have, it's have more speed. It's capable of connect with other transistor, other qubits, and this is the secret of the quantum computing. And my partner Jacqueline will talk to you about how this will change our lives. So yeah, for me this is very interesting. It's a very interesting topic. It's not common for anyone, and it's hard to explain. Both in the research paper and in the essay, I try to explain you in easy words, but yeah, it's very interesting, and thank you for watching.
Okay, so in areas where today's computers would require billions of years to solve some of the world's most complex problems, quantum computers could find the solution in just minutes, hours, or days. Here are some surprising applications which can be developed exponentially thanks to quantum computers. First off is machine learning. Artificial intelligence must be able to analyze large data, sets of image, videos, and text. At this time, there is no shortage of data. We could say that it is a phase of overabundance. Quantum computers will allow more data to be analyzed and managed in much less time, thanks to their power to process the petabytes of data that have not yet been analyzed. Also, quantum computers could power multisectoral machine learning by allowing all programs to search these gigantic data sets for items related to medical research, consumer behavior, and financial markets and make sense of it. One is the optimization. Each process can have a number of variables with quantum computers. A machine can be able to handle almost innumerable permutations and combinations, which could advance the design and analyze of systems in a massive way. For the logistics sector, optimization is the common denominator of all transactions and processes. Classical computing is used for organization of shipments, fleets, data management in real time, etc., which in the long run can become too complicated. These processes or a classical solution, so a quantum approach will become a great alternative. You have to think that the physical internet, which is something that we could also talk about, but it's just another theme, and which promises to be the definite engine for optimizing global logistics and will require a large amount of real-time processing to be operational. In quantum computing may be the ultimate solution for your implementation. Also in biomedical simulations, quantum computers will be able to create, simulate, and model molecular structures. Back in Harvard University in 2012, a quantum computer, exactly D-Wave 1, was used to figure out the way some proteins fold. Moving on to financial services, the first commercial quantum computer, the D-Wave 2000Q, has been implemented by D-Wave, a company backed by Goldman Sachs and Bezos Expedition. It is a quantum system with 2000 qubits and advanced function controls. The system could be used for complex financial modeling and risk management within the financial industry. It can help you find new ways to model financial data and isolate key global risk factors. There are many more things in which this can help us more because we are no longer in the past. Technology is already something fundamental in our lives. We literally cannot live without technology anymore. And if with this we can make a change and help the environment, health, education, it is much better, and I believe it is really effective.